This is question 10 from the 2022 AMC10A. And the question is, Daniel finds a rectangular index card and measures the diagonal to be 8 centimeters. Daniel then cuts out equal squares of side 1 centimeter at two opposite corners of the index card and measures the distance between the two closest vertices of these squares to be 4√2 centimeters, as shown below. What is the area of the original index card? First of all, since we're working with a figure, we can draw in fill in these squares to make it more obvious what's going on. Second of all, we can notice that this here is still a right angle, obviously. And so here we're going to define this side length to be x, this side length to be y. From here, we can easily take x squared plus y squared equals 8 squared. This is just the Pythagorean theorem on the triangle ABC in this case. Okay, and now we're going to do a similar thing by drawing some auxiliary lines in to make a similar equation. Now, this here is a right angle because, well, it should be pretty obvious if we define it as so. And you can find this to be y minus 2 and this to be x minus 2. So the reason we know those is because this is also 1 by 1. So this whole length of x gets subtracted by 2, unless we lose 1 on the left side and we lose 1 on the right side. Minus 1, minus 1. Okay, now so we can put that into the Pythagorean theorem by doing x minus 2 squared plus y minus 2 squared equals 4√2 squared. Now we can expand this. We can get something like x squared minus 4x plus 4 plus y squared minus 4y plus 4 equals 32. And from here we can notice that these two terms, actually we already know the value of, which is 64. So we can replace these with 64. 64 minus plus 8 minus 4x minus 4y equals 32. And then if we do a little more simplification, we get that negative 4x plus y equals negative 40, which turns into x plus y equals 10. Now, we can move it over to the right side here. So knowing that x plus y equals 10, a common trick, considering that we know x squared plus y squared, and we know x plus y, is to try to find x, y. And in this diagram, that is particularly useful because we're not just working algebraically. X, y is actually what we're looking for because we're trying to find the area of the index card. And well, should be pretty obvious by now, but x, y is the area of the index card. So let's try to find x, y. To do that, we can square this. Y squared equals 10 squared. X squared plus 2xy plus y squared equals 100. And then these terms are 64. So 2xy equals 100 minus 64. 2xy equals 36. Xy equals 18. And there's our answer, E.